Hello students, welcome back to my channel. In today's class we are going to study about the chapter alcohols, phenols and ethers. This chapter is having 4 to 5 marks weightage in the board exam. So we are starting today with the topic of preparation of alcohol. So here we are talking today about preparation of alcohols. So in the preparation of alcohol, let's see that preparation of alcohol can be done by 3 ways. Preparation of alcohol can be done by 3 ways. Now what is the first way? The first way is how can we prepare alcohols from alkenes, and this reaction, few more concepts of this reaction you have studied already in your class 11th. Okay, so first one is we are going to prepare the alkyl from alkene, and from alkene also we will be studying 2 steps. First step is by acid catalyzed hydration, and second one is by hydroboration. Now let's see that what is the second way of for preparation of alcohols, and the second way is we can prepare it from carbonyl compound. Carbonyl compounds, it means the compounds which are having, let me explain about carbonyl compounds. Carbonyl compounds, it means the compounds which are having C double bond O linkage. Okay, now when we will study about carbonyl compound, we can see that here also we need to study. First we are going to study this, that is the reduction of aldehydes and ketones, and second one is, which we are going to study, is reduction of carboxylic acid and esters. Carboxylic acids and esters. Now third part for the preparation of alcohols is, this is the first, second and third part is from Grignard reagent. Now let's see student, when we will be studying about all these methods of preparation of alcohol, at that time we can observe that whenever this type of questions will come in the exam, they won't be asking you directly write down the preparation of this or that. They'll ask you the conversion of that particular conversion means what? If I am saying that aldehyde, how the aldehyde will convert it into alcohol, how if I am talking about alkenes, so how alkenes are converted into alcohol, that we need to see and that we need to study also. Now let's see the topic one by one. Okay student, so let's start with preparation of alcohols from alkenes by the acid catalyzed hydration. Now in the acid catalyzed hydration, let's write one general reaction for this, and in general reaction I will show you in this way. If we have alkenes, I will be writing in this way as, if we have alkenes, and when in alkenes, whenever we are adding water to it in the presence of H plus ions, these alkenes will convert it into alcohol, and we can prepare alcohol in this way. Okay, so here I am writing H and it becomes OH. So in this way, this is actual the reaction of acid base catalyzed hydration. And student, do you know that this reaction can be asked in the exam also, and this is one of the most important reaction of organic chemistry, and that one is for conversion as well as for mechanism. So we will write here as IMP. Now let's see the mechanism of this reaction, because this mechanism often asked in the board exam. Now mechanism we will start, and this mechanism consists of 3 steps. Okay, now try to understand properly. First step I will be writing here, and that one is protonation of alkenes. Now let's see what do you mean by protonation of alkene. So protonation means what? Protonation, it means proton, and proton it means H plus. Okay, and here the reaction which is going on, that reaction is actually according to the Markovnikov's rule. Markovnikov's rule. Markovnikov's rule we studied in class 11th. It means, and Markovnikov's rule says that the OH, right, or the negative part of the adding molecule is going to that carbon atom which is having less number of hydrogen. That rule we know very well, and this is also occurring in terms of Markovnikov's rule. Now let's see its mechanism. The mechanism is, that is the protonation of alkenes. How we are going to see that? In the protonation of alkene, as we know that we have water as well as H plus ions. So in the first step, this water, now you know very well the water is having two lone pairs, right? So these two lone pairs and H plus ions are there, and we know the tendency of oxygen. And what is that tendency? The tendency of oxygen is to give electron pair or lone pair to someone, and that's why this lone pair would be given to this H plus and taken by hydrogen, and then it will convert it into H3O as one lone pair, and this will also have a positive charge, as oxygen is having positive charge. And why that oxygen is having positive charge? Because it is given his lone pair to hydrogen. Okay, understood? Now let's see that when it, okay, so here is a formation of H3O positive, and that one is hydronium ion. Now we have carbon-carbon double bond, and on this carbon-carbon double bond, when this hydronium ion comes in contact with it, now see, properly understand what is the tendency of oxygen. The tendency of oxygen is, first of all, oxygen only given his lone pair to someone. Now oxygen is again asking back that lone pair, because he wants to become a stable, and hydronium ions are not that much stable as compared to the water molecule, and hence these are, when we are what this oxygen is doing. Oxygen is actually, I'll show this with the different pen, and that one is what oxygen is doing. Oxygen is taking back this lone pair. Okay, what oxygen is doing? Oxygen is taking back this lone pair, and as soon as the oxygen is taking back this lone pair, this hydrogen become alone and it becomes H plus. It becomes H plus. Now to help to this hydrogen, this carbon will donate out of these two bonds or two electron pair. This hydrogen will donate its one electron pair to hydrogen, and then in this way we can say that it becomes, see, one electron pair has given to CH, so that's why it becomes H, and as this carbon has donated his electron pair to another carbon, that's why this carbon will acquire positive charge. This carbon will acquire positive charge. Now why this carbon has acquired positive charge? Because he has given his lone pair to another carbon atom, and as soon as he has given, and it becomes like a H2O molecule. So this is the first step, and that one is protonation of alkanes. So in protonation of alkanes we will be studying that, yes, alkene has taken one hydrogen from the water and it becomes protonated. Understood? And as he has taken the protonated, and that's why it becomes positively charged. Okay, now let's see. In next step there is a nucleophilic attack of water. There is a nucleophilic attack of water. In nucleophilic attack of water, how can we study? See, in previous step we got this as a carbocation, and we have water also. I am writing water formula in this way to understand properly and to see its electron pair. Now what will happen? This water will donate its electron pair to carbon, because carbon is electron deficient, and as soon as it will donate its electron pair to carbon, then it becomes like this one. So O will join attached from here, and one lone pair, here one H and then H, and it will acquire positive charge. Why positive charge? Because he has given its one electron pair to carbon. Now, so here we got the product after nucleophilic attack. Now see that in the step 3 there would be deprotonation of, or we'll say it as a deprotonation to form alcohol. How it is occurring deprotonation? Let's understand. Okay, so see this one, H and H, and then it would be positive. So in this one we can understand that deprotonation, what is the tendency of oxygen? Oxygen tendency to whatever electron pair he has given to someone, he wants that electron pair back, and when he wants that electron pair back, then he has to release this hydrogen. He can release this hydrogen or this one, any one hydrogen he'll release and convert it into OH, which is an alcohol. We can write here as H also. Here also we can write H because we have received it from hydronium ion, and in this way we can get alcohol molecule. So now what we have studied in this topic, that is the acid base catalyzed hydration. This is one of the mechanism, and this mechanism contains 3 steps. And what are those 3 steps? One more time here I am writing. So first step is what? In the first step we observed that first step was protonation of alkenes, and second one is nucleophilic attack of water, and third one is deprotonation to form alcohol. So this is one of the very important concept, and student, if you are not understood this, please write in the comment section that what you have not understood. I'll make you to understand that topic one more time. Okay, so after studying this, let's see the second preparation of alcohol. Okay student, so let's see the second step. In the second step, it's a bihydroboration of oxidation. In hydroboration, it means we are using diborane. The formula of diborane is B2H6, but I am writing to make it more clear, I am writing it as an expanded form, that is H and BH2. When this H and BH2 will react on propene, they can form this as a diborane product, right? And then one more molecule will react and we get it as a diborane product, and finally we can get this product, and this product is trialkyl boranes. And this trialkyl borane, that is CH3 CH2 CH2 trialkyl boranes, is actually reacting with H2O2 in the presence of OH negative. It means it is present in the alkaline medium. So this trialkyl borane reacts with hydrogen peroxide to convert it into CH3 CH2 CH2 OH, and that one is alcohol, and by the byproduct we can get it in this way. So this is one of the preparation in which we can observe that how we can prepare alcohol from diborane. And the previous one which we have studied, that one is the most important. This is also important, I am not saying that, but this question they'll directly here, rather than doing all conversion, you can do directly as a trialkyl boranes to alcohol in the presence of H2O2 and alkaline medium. Okay, now let's see the second way of formation of alcohol, and that second way of formation of alcohol is, as in that ray diagram we have studied, and that one is from carbonyl compound. So second way is what? From carbonyl compounds. Carbonyl compounds means what? Carbonyl compounds, it means those who are having this linkage, that is C double bond O linkage. As we know that aldehydes, ketones and this carboxylic acids and esters, all of them are having this linkage, and this one is very easy concept. How we need to write? We need to write it as a aldehydes or ketones reacts with, or they will use some reducing agent and it will convert it into alcohol. I will give you few examples. As we know that few examples are platinum, nickel, palladium, and then NaBH4, or we can say that LiAlH4. These all are reducing agent, and this lithium aluminum hydride is one of the very expensive reducing agent. That's why we are using that for some specific reactions. Otherwise we can use this all reducing agent. Now how can we solve this? Let's see. I'll give you one example. Like first one is, if we have acetaldehyde, and when acetaldehyde reduction, it's a reduction, so that's why in the presence of nickel or platinum or palladium, it can be converted into CH3CH2OH. So they are converting it into primary alcohol. Or if I'll take another example of it, and that one is any ketone. Here I am taking it as a acetone. So acetone, when reacts with H2, that is hydrogen, we can use another also, NaBH4, and it can convert it into alcohol. It can convert it into alcohol. So here we can observe that it's a primary alcohol and it's a secondary alcohol. It means specifically when we are observing from carbonyl reduction, or we'll say that from carbonyl compound, or we'll say that by the reduction of carbonyl compound, we can observe that aldehydes yields primary alcohol, acetone yields secondary alcohol. Okay, so now let's see how can we observe this for carboxylic acids and esters. Similarly, carboxylic acids and esters also, we can use the same reducing agent there also, and we can observe this as carboxylic acids, that is RCOOH. This is carboxylic acid. Carboxylic acids are reacting with LiAlH4 followed by hydrolysis, and we will be getting it as CH3CH2OH. Student, one more thing we need to keep in mind whenever we are writing any reaction, and in that reaction one or two more catalysts are we are using it, then we can write those catalysts in terms of like 1 and 2. What does it mean? It means that first we added LiAlH4, and then when we got the intermediate product, then we added the second reagent, and if we are writing in this way, nobody can give us wrong for that. So we can write in this way. Now if we have esters also, now if I have esters also, that esters will also convert it into alcohol. Or another method of converting that one is, if I have this one, what is this? This is a carboxylic acid. Carboxylic acid, when carboxylic acid reacts with alcohol, we know that they can form the esters. What is this? These are the esters. So esters on reduction with platinum, palladium, or any reducing agent, this can convert it into RCH2OH, and at the same time we can get another product also there, and that would be ROH. So okay, so esters can also be converted into alcohol, and this carboxylic acid directly also can be converted into alcohol. So this is the second method of preparation of alcohol. Now let's see. Okay, so third step is from Grignard reagent. So for Grignard reagent is specifically for carbonyl compounds. Now let's see the mechanism of it. So in mechanism we can see that if we have this is as a carbonyl compound, this will acquire partial positive charge, this one will have partial negative charge. Let's take Grignard reagent, that is RMgX. This X being halogen, it will acquire partial negative charge, this will have partial positive charge, and here we can get it as a partial negative charge. So this R will attack on this carbon, and as soon as R will attack on this carbon, it is having negative, so this will do attack on this oxygen, and we will be getting product adduct. I will be using this word as adduct. Adduct, it means intermediate form in between. So let's see. Here intermediate is forming in this way, as one will attach with R and another O will attach with MgX. Okay, so we will be getting in this way as a adduct. Adduct, it means intermediate formed in that reaction. And when we are doing hydrolysis of it, simply we are getting it as a, we are getting product as hydrolysis. So here it is R, then it becomes OH plus, so from here it will get breakdown and we will be getting as MgX, and here it becomes OH. So this is actually the mechanism of Grignard reagent. So by this way we can solve some questions also. If we have CHO, no need to write every time the mechanism and the adduct which is formed between. Directly also you can write the question, and that one is, what is this? This is formaldehyde. This is formaldehyde. Formaldehyde reacts with RMgX to form. Okay, now what product we got in this way? So simply we will be writing, and in place of carbonyl oxygen we need to write it as a H. So I will be writing here as H already there, one H is already there, then R, and it becomes OH. So I got answer as RCH2OH. Okay, got it? So in this way we can write its product, and final product we know. Okay, so this is for formaldehyde. Then now it would depend upon RMgX. Now I will be giving some proper examples and I will make you understand about how these Grignard reagents are forming alcohols. For conversion student, this is one of the very important reaction. For conversion, how I can do the conversion? For example, now if I am writing acetaldehyde, acetaldehyde reacts with RMgX. In place of RMgX, I am taking it as a CH3MgCl. Now, what is the name of this compound? This compound name is acetaldehyde. Acetaldehyde reacts with methyl magnesium chloride. That is RMgX or Grignard reagent. When acetaldehyde reacts with this one, we can get this product as CH3C, right? Then one H also we need to write, H, and one R. In place of R, CH3 is there. So CH3, and here we will be writing it as a CHOH. Okay, so here we are getting this, we got it as a primary alcohol, and in this situation we got it as a secondary alcohol. Okay, secondary alcohol. I can write this way as a secondary alcohol. So, and byproduct would be MgOH and Cl. Similarly, student, we can solve one more question. So this is first, second, and now third. In third, I am taking acetone. Formula of acetone is CH3C double bond O CH3. Okay, so in this one I can write here as, when it will react with, again I am taking it as a CH3MgCl. So it will react and we can get product as CH3, then one more CH3 double bond not double bond, single bond OH, and if you understood the mechanism easily you can write its product. And there are many, I cannot take all the examples here, but in this way you can write the product. So here we got it as a primary alcohol, secondary alcohol, and then tertiary alcohol we can get. So in this way these all are the preparation of alcohols, and that one is from Grignard reagent. And student, I hope you understood today's topic, and whatever I taught in today's class, you need to do practice of it. Take your pen and copy. If you have any kind of doubt, please note it down and then ask me. Thank you students, and have a good day ahead.